Okay, so let's start, Aniruddha. Shall we start? Hello.
Sir. Yes.
Okay. Okay, so first of all, this is the topology. Okay. So what we have here, switch 1, switch 2, R7, R8, server 1, and user, right? So as we can see in this diagram, what we are running here, OSPF area 0. Okay, in this whole diagram, we have layer 3 switches, switch 1, switch 2. They will be having SVI to form a OSPF neighborship with each other. Okay, and with R7, R8 also. Now, server 1 is connected to VLAN 100, 200. This user is connected in VLAN 100. Okay. And finally here, what we need here, we need to have a communication. So here we can see SVI. The address is 100.1. So what is this 100.1? These routers and servers and these switches are using the same subnet, that is 172.16.0.x. And what is your X? X is your 100, 22, 10, 18, 17, 13.6.5. Okay, so the common subnet is 172.16.0 on /30. Okay, this is clear. The IP addressing is clear, I think, right?
Yes.
Okay, so let me show you the task. What task we have here? So the first is your switching troubleshooting. Okay, the user that are located in the VLAN 100 have lost access to server which is located in VLAN 200. Fix the problem so that the following sequence of commands produce the same output. Okay, so what I need here, we have to do a communication from this user to this server. Okay, so this user is in VLAN 100, this server is in VLAN 200. We have to do a trace and a ping, and that should go via like this. The first hop should be .1, it means the gateway address. The second one should be .21, and then finally it goes to real server. Okay, so first of all, here we have 100.1. This is the first IP address, the first next hop. Then it should go directly to switch 1. You can see the address .21 and then directly jump to server 1. So we need a trace route, user, switch 2, switch 1, and then finally server 1. Okay, so I think the task is clear, right?
Yes.
Okay, any doubt till this point to understand this diagram?
Area 0 consists of switch 1, switch 2, and R7, R8, right?
Right, correct, right.
Okay.
And in between switches, we are using a trunk port. So over trunk, we are using SVI. So using that SVI, they will communicate, they will form a neighborship. Okay.
Okay.
Over trunk, we are using this one.
Okay.
Okay. And same here, we have some interfaces in VLAN. So that switch 1 will be having SVI, and over the VLAN, it will send the packet out to R7, R8, and switches, and they will form the neighborship like this. Okay. One more thing here. In between R7, R8, I can see VLAN 78. So these are the routers, and we cannot configure any VLAN on the routers, right? So how this is possible? Any idea? In between R7 and R8, we have VLAN 78, right? So on routers, we cannot configure VLANs, right? Directly, we cannot configure. So how is this possible? Okay. So in the background, we have a switch, and over the on that switch, we are using this VLAN 78. Okay. So using a switch, these routers R7, R8 are connected. Okay.
Okay, so we are using a switch in the middle.
Yes, correct. Okay. So now I'll open user and we'll do a trace and we'll see what will happen here. Okay. So this is the user. Okay. So I will try to do a trace. Let me do a ping 172.16.200.200. So this is the address of server 1. Enter. So right now, as I can see here, unrecognized host or address or protocol not running. So it means we do not have any address on this user. So let me check the IP address. Show IP interface brief. Okay, so on E0 by 0, we do not have any IP address, right? So that is configured for DHCP, but right now we are not getting any address here. So now we have to check the connectivity. Okay. So we'll check the connectivity one by one. And who's the DHCP server? R7 and R8 might be the DHCP server. Okay. They both will be having pool. If they do not have any pool, so we have to configure here pool. Okay. In this diagram, for server 1 and for this user, who is the DHCP server? R7 and R8. Okay. So what we will do, we will check one by one. Okay. So we'll go to switch 2 first of all. Okay. And we'll check, do we have any SVI here with this address? Okay. So that's the first part that we have to check here. And how we identify which interface is connected to me and which interface is connected to switch 2. So we have to check that thing also. What we can do, simply type show CDP neighbor. So using this command, what we can do, we can check the interface connectivity, right? Enter. So as I can see, the local interface is E0 by 0 that is connected to switch 2, and the remote port ID is 1 by 0. It means I'm having 0 by 0 itself, the PC, right? And switch 2 is having E1 by 0. So we have to verify the switch should have this port E1 by 0 in VLAN 100. Then only they can communicate, right? So let's go to switch 2. So we have to check 1 by 0. Do show interface status. So in this status, we can see that port is available or not, that is shut down, that is in error disabled. So whatever state we have, we can see here, and the VLAN also we can verify. So this is the command we use to verify the interface status and the VLAN. So E1 by 0. So look here. On this interface, we can see we are having 101 VLAN, right? But that should be VLAN 100, correct? So this is the first issue here, right? So the first thing we have to check the interfaces, the real interfaces, and using this command show CDP neighbor, we can see the interfaces. Okay. Now we have to change this interface with VLAN 100. Okay. Let me just verify. Yeah, this is 1 by 0. Cool. In the configuration mode, interface E 1 by 0. Interface E 1 by 0. Switch port access VLAN. Yes, Anirudh, any doubt?
Yeah, no. I just
So switch port access VLAN 100. Okay, just go back. Do show interface status. Okay, so right now that is a part of VLAN 100. Now we have to verify the VLAN SVI should have the address 100.1. Okay. Do show IP interface brief. So earlier we were checking the VLAN. It means layer 2 functionality, right? So that's why we have to use interface status command. If I want to check the layer 3 connectivity, so we have to run the show IP interface brief. Okay. Now, so look here. We have these SVI for VLAN 12, VLAN 27, VLAN 28, and VLAN 100. Okay. So in this VLAN 100, as I can see, the address is 172.16.100.100, right? But it should be 100.1, correct? So as this is mentioned here, this should be 100.1. So we have to change the address here. Interface VLAN 100. Do show run interface VLAN 100. Okay, so this is the address here. IP address 172.16.100.1 255.255.255.0. That's it. Okay, and finally, as I can see in the diagram, we should get .100 here on the user, not on the SVI. Okay, so this connectivity is done. Now we have to verify switch 2 should have one neighborship with switch 1, one neighborship with R7, one neighborship with R8. So right now we will check the OSPF neighborship. Okay. Go to switch 2, do show IP OSPF neighbor, run this command to verify. So right now, as we can see, we have just one single neighbor, that is R7. So we have to verify what is the issue in between switch 2 and R8, and the same in between 1 and 2, switch 1 and switch 2. Again, first of all, we have to verify which interface is connected, right? So do show CDP neighbor. Let's start with R8. So as I can see here, R8, that is connected to my local interface 1 by 2 and 1 by 1. So now we have to verify these two interfaces should have VLAN 28. Okay. So E1 by 1, 1 by 2 should have access of VLAN 28. Do show IP, do show interface status. So 1 by 1 and 1 by 2. So look here, we have a different VLAN here, correct? So 1 by 1 is on 100, 1 by 2 is on 78. So we have to change the VLAN here to 28. Interface range E 1 by 1 and 2. Switch port access VLAN, that is 28. Just give it. Do show interface status. Just verify the commands. Okay, that is done. Do show IP OSPF interface brief. Okay, so you can see here OSPF is configured on all the interfaces, and here you can see now we have another neighbor on the VLAN 28, right? Perfect. Do show IP OSPF neighbor, so that neighbor is up. Now we have to verify why this interface is in down state. Okay, so the VLAN 12 we are using with switch 1. Okay, so let me show the diagram first. Over this trunk port, switch 1, switch 2 will form the neighborship with VLAN 12. The first thing we have to verify the trunk port is available or not. Okay, if that is available, the VLAN 12 is working or not. Okay, go to switch 2. Do show interface trunk. So as I can see, the trunk port is available, right? But here we cannot see VLAN 12, that is removed here, right? So I'll just run one single command, interface range E3 by 0 to 3. So Anirudh, any idea what command we can run to add VLAN 12 here? Any idea if you have?
Uh, I did, sir, but I don't remember.
Okay, no worries. So we can run a command switch port trunk allowed VLAN. We have to add another VLAN. We have multiple options here, right? So we have to add another VLAN. So add VLAN to the current list, right? If I type a VLAN 12 like this, so what will happen here? The device will remove all the VLANs and will just allow 12, but we need to add another VLAN. So we have to say add.
Okay.
Add 12. Just say exit. Do show interface trunk. Okay, that is allowed now. Okay, let's check the interface status again. Still, that is in down state. So now we have verified two things. One, trunk is up, VLAN 12 is available on the trunk port. Now we have to verify that VLAN 12 is available in the database or not. Okay. Do show VLAN brief. Enter. Okay, look here. So if your SVI is down, it means that VLAN is not allowed on any interface, right? That is allowed, but right now that is not in database, correct? So let's configure the VLAN 12. Enter. Do show VLAN brief. Okay, so I have configured VLAN 12, but again, I cannot see that VLAN 12 in the database. Any specific reason, Anirudh? Anyone, any idea? Why I cannot see the VLAN in VLAN, here in the database?
to give no shut thing there?
No, we never run the no shut command. We run the no shut command on the layer 3 interface. This is a layer 2 VLAN, right? So we have configured VLAN 12. It means we are doing a layer 2 configuration right now. But again, I cannot see that thing, that VLAN in the VLAN database. The reason behind this. Okay, what happens here? Whenever you configure any VLAN, right? So it will wait for the exit. If I need any modification, let's say I want to configure a name here, I want to do any modification, any other state I want to set here, right? So that task I can do. So once I will exit from this mode, then this device will execute this command. Okay, so this is a single feature. The device will execute after exit. Okay, let's say I'll configure IP address, I'll configure interface, I'll say no shutdown. So those commands will execute automatically at the same time. But right now, only for the VLAN, once I'll configure a VLAN, we have to say exit. Correct. Okay. So just say exit. And now we can see that VLAN here. So let's go back to OSPF, do show IP, OSPF interface brief. Okay. So that is in wait state. It means that is up and running. Okay. So just wait for another 40 seconds, because in OSPF, whenever a device, whenever interface form a neighborship with another one, right? So that will take 40 seconds to form the neighborship. In the background, that will do those elections, those states it will run. Anirudh, your voice is too low. I cannot hear you.
Yes, sir.
Yes, Anirudh. Any question?
No, sir.
Okay. Okay, so that is DR, but we cannot see any neighbor count here. So we have this one, neighbors F and C. So the F, it means that is your forwarding, how many neighbors we are in forwarding state, the number of count, how many neighbors we have, how many neighbors are in forwarding state. Okay, forwarding and count. So that can be different, can be same. Now, so basically if we have, let's say, a serial segment, so this will always be 1111 always. Okay, if we have Ethernet segment, so in that case, if we have, let's suppose, n numbers of user, so that time the total number of count will be having here the total number of neighbor count, and then here it will be two, one for DR, one for BDR on the DR other routers. If I'll talk about DR router and BDR, so that time the count and then forwarding both will be same. Okay, I hope you are aware with these things like the forwarding, the count, and the DR BDR election. Okay, now so what I'll do here, I'll go to switch 1 and we'll check the same configuration. Okay, because right now the VLAN 12 neighborship is not up. So Anirudh, any idea what we can verify first?
No, sir. Not sure.
Okay, so basically first of all I will check the trunk port that is available or not. Okay, do show interface trunk. Okay, but again the same issue, the VLAN 12 is not here. Interface range E3/023, switch port trunk allowed VLAN we have to add 12, exit, do show VLAN brief. Okay, again that is not present here, VLAN 12, exit, do show VLAN brief. Perfect. Do show IP OSPF interface brief. Okay. So look here. That VLAN is up and we can see the neighbor count and that neighbor is in forwarding state. Okay. So any doubt on till this point? So any doubt on you? Nah. So the neighborship is up, right? What we have to do here, the user should get the IP address. This user should get the IP address from these DHCP servers. So now we'll verify R7 or R8 is having a DHCP server or not. So let's start with R8. So any of these devices can have the DHCP pool, either R7, either R8. Show run pipe section DHCP. So as we can see in the diagram, this should get always .100. It means we have to configure a host pool, not a network pool. Okay. Now, so as I can see a pool, Banco Bank VLAN 100 host 1. It means this is the pool for this user. Okay. But I can see the wrong IP address. So first of all, I will change the IP address here. The host should be .100. Okay. Client identifier. So this is using 01 and the MAC address of the user. So let's go back to user and we'll check the real MAC address of the user. Okay. Show interface E0 by 0. Just to copy and paste. So this is BIA, one in address. So just remove the previous one. Client identifier, put 01 as a prefix, we can say, and then the MAC address of the user, enter. WR to save the configuration. Okay, so this is done. One more thing here, the default router should be .1, correct? Because here, as I can see, the gateway address should be .1. So just change this default router also. 172.16.100.1, cool, do WR. Now, R8 is a DHCP server. Switch to have to relay the packets, correct? So that should be your relay server, DHCP relay server. So let's go to switch to and check the configuration. What we have to check here, we have to check the relay configuration on the SVI. So in this case, what will happen here, switch to will always receive the broadcast packets on the SVI VLAN 100, correct? So what we have to do, we have to go to SVI VLAN 100 and have to check the configuration for the DHCP relay server. Okay. Now, do show run interface VLAN 100. So as I can see here, we just have an IP address. We do not have any relay server address. We have to use helper address command to set the relay server. Okay. Interface VLAN 100. IP DHCP. Sorry, that's helper address. Interface VLAN 100. IP. The command is IP helper address. Yeah. IP helper address. So the address of R8. So we have to go to the R8 and have to check one loopback address of R8. So, okay, so do show IP interface brief. Okay, so the loopback address is 172.8.8.8.8. 172.8.8.8.8. That's it. Okay. So now let's go to user and verify like that is getting the IP address or not. That should get the IP address now because everything is fine till this point. Show IP interface brief, still not getting the IP address. Just do one thing, say shutdown, no shutdown to the interface, just flap the interface and it will initiate the packet again, shutdown, and then say no shutdown. So once I will say here no shutdown, it will start initiating the packets. Do show IP interface brief. Okay, perfect. Okay, right now we are getting the address 172.16.100.2. So we should get here 100.100 using the host pool. Right now, the device is getting the IP address from the network pool, not from the host pool. Okay, so just go to R8 again and verify the issue. Okay. R8. Do show run pipe section. DHCP. Okay. So the device is using this port. Let's verify what is happening here in the background. Do show IP DHCP binding. Okay, so the device is using this MAC address that is getting the to AAB. Okay, so let's go to PC again, verify the MAC address. Okay, one more thing here. If our interface is using modified address E0 by 0, so look here, we are using a modified address, so we have to use this address. Okay, what we can do, we have two options. We can change this address, we can remove this address from here, or we can copy and paste this address into the DHCP pool. Okay, so just do one thing, copy and paste in the DHCP pool. So whenever you modify the MAC address, so the device will start using the modified address. Go to R8. No client identifier. Client identifier 01, paste the address. Okay. Go to QR. Clear IP DHCP binding star. Okay. Now we can go to next device, R101. You can see shutdown, no shutdown. Just wait, it will take time to get the IP address. Do show IP interface brief. Okay, so we are getting the IP address. Okay, so let's do a trace. Okay, do trace 172.16.200.200. Use a numeric keyword, the fast trace route. Okay, the first hop is .1, the second hop is .21, and the last hop is this one. Okay, so this we have to match, and this task is done. Okay. So now guys, you can tell your doubts if you have any doubts. Okay. Shashank, Vishal, Faraj, Abhilash, any doubt if you have, you can ask. Anirudh, any doubt in this ticket?
No, sir. For now it is okay, sir.
Okay. Everything is clear, right?
Yeah. Yeah.
Okay. Shashank, Srivastav, any doubt? Dharamveer, any doubt? Vishal, Faraz, if you have any doubt in this diagram, in this topology, you can ask. Okay, so I hope this ticket is clear to everyone, right? Okay, cool. So let's start the next ticket. What is the difference between network pool and host pool? Okay, so Abhilash, you have this question, what is the difference between network pool and host pool? So in the network pool, basically what we define a pool of range. Let's say we have a LAN. Okay, in the LAN, we have 100 users. So at that time, I will configure network pool. So that pool will be having a number of the range of addresses, right? And if I'll talk about the host pool, let's say we have an admin, a special admin, and what I want, whenever that admin will connect a laptop in the LAN, so it should get always .100, .200, a specific IP address. So what we do there in the host pool, we map the client MAC address and the IP address there. So whenever that client MAC address will come and will ask for the IP address, the device will exactly give the same address .100. So if I need a specific address on a specific laptop, so we configure host pool, and for the LAN, we configure a network pool. Okay, Bilash? Faraj, we are doing this troubleshooting session, okay? So this will be having layer 2, layer 3, triple P, troubleshooting, OSPF, EIGRP, BGP, everything this will be having. So this is our troubleshooting section only. So we have a topology, we have to find the issues, we have to fix those issues in this session, okay? Yes, your MAC binding. This is your MAC binding. Yes, Isham, ask your question. Okay, so if we have a pool of 10 and user will be 11, okay, so if the 11th user will come there, okay, so in that case, the user will never get the IP address, never, because all the addresses are available, right? So we have a single pool that has a power to give the address of only 100, okay, so that time, uh, what happens at that time basically, so it will check, do I have any available address? No. So at that time, the 11th user will never get any IP address, okay? Any other doubt? Okay, so if you don't have any doubts, so we can move to next step. So any doubt, guys? Okay, so let's move to the next step. Okay, so in the next ticket, what we will discuss triple P, point-to-point connection. Okay, so we have local service provider connected to R11, has lost access to R17. So this local service provider gateway must authenticate their triple P subscriber using CHAP. Okay, so we have to configure here CHAP. Okay, now the subscriber must have a default route in their routing table pointing to local service provider. So we have two requirements here. We have to, first of all, we have to configure triple P here. The second thing, we have to configure CHAP authentication. The third thing, we have to configure a default route. So we should have these three requirements here. And then finally, we have to do a telnet to this address. So now let me show you the diagram. So look here, we have R11, we have R12, and we have R17 here, right? So in between R12, R17, what we have here, we have triple P session. Okay. So R17 basically will be your triple P client. R12 will be your triple P server. Okay. And then finally, once we'll be having everything, R11 should do a telnet to R17. Okay. So the first requirement, I will go to R17 and will verify that we are getting IP address from R12 or not. Because R12 here is our server for triple P that will provide IP address that will authenticate R17 and will give a default route to me to do the communication. Okay. I think the diagram is clear. So guys, any doubt in this diagram? R12, R17 and R11? Anirudh, any doubt?
R12, R17 and R11. Sir, where this, okay. Yeah. Okay.
Okay, so R17 will be a triple POE client. R12 will be the triple P server, and R11 finally it will do a telnet to R17. Okay.
Okay.
Okay, cool. So I'll start R17. Okay. So as I can see in the diagram, we have S4 by 0. Interface S4 by 0. Let me check the configuration. Do show interface S4 by 0. So as I can see here, the encapsulation is frame relay, right? Now, the first thing we have to change here, we have to configure the encapsulation that should be triple P because this is the task of triple P. Okay. So interface S4 by 0, encapsulation triple P. Now the next thing, we have to get the IP address from R12. So just run one single command, IP address, negotiate. Okay. So now R12 will provide the IP address. So it means that should have a pool. So what we can do in triple P, we can choose two types of pool. One we can choose that is a DHCP pool. One we can choose that can be a local pool. Okay, so let's go to R12 and we'll see what it is using. And before this one, just shut down the port. So once I'll do everything, I will say no shutdown, and then it will start negotiating the information. So do show run interface as 4x0. Okay, so here as I can see the triple P encapsulation is configured. Triple P default IP address DHCP pool Uber market spoke 1. Okay, so right now this is using a DHCP pool with this name, right? Okay, and one more thing here, the command here we have triple P IPCP route default. So if you are aware with the triple P configuration, we always configure this command on the client side, not on the server side. So right now R12 is acting as a server, so we have to remove this command. Okay, interface as 4x0, just say no triple P IPCP route default. Okay, we have to remove this command because that should be on the R17 on the client side, not on the server side. Okay, now check this DHCP pool. Do we have any pool there or not with the same address? So that should have this address .22. Okay, so I'll be using a pool here in the DHCP pool. Do show IP DHCP pool. So right now, as I can see, we do not have any pool. So I have to configure a new pool, IP DHCP pool. The name should be same as this one because that is already configured. Enter. Okay. The network 145, 67, 89, 20, put on /13 with a space. Just say exit, no worries. So, okay, so using this configuration, it will get the default, it will get the IP address. Now about the default route, go to R17 and run the same command, triple P IPCP route default. It means using triple P IPCP, it will get a default route from the neighbor. It will negotiate the default route. Interface as 4x0, triple P IPCP route default. Okay, cool. Now the last requirement. The local service provider gateways must authenticate their triple P subscriber using CHAP. So we have to use here a authentication that is CHAP. So we have two types of authentication here, CHAP and PAP. So right now we have to configure CHAP. Okay. So go back to R12 and configure some local database. Username CCIE, password CCIE. Okay. Interface as 4x0, triple P authentication CHAP. That's it. So once I'll configure this one, triple P authentication CHAP, it will start doing authentication using CHAP and will check the local database to verify the authentication. Okay. Now let's go to R17 back. Run the command here, triple P CHAP host names. The host name is CCIE. Triple P CHAP password is again CCIE. Enter. So now everything is done here. Okay. Shivam, you have a question. Triple P IPCP default route command is used for, okay, so this command we use to get a default route from the triple P server. Let's say we have two things. One, we have ISP, one we have client. And in between ISP and client, what we have triple P connection. Okay. So at that time, the client should get a default route, right? And how that PC will get a default route, that client will get a default route using this command, triple P IPCP route default. So once a client will run a command, triple P IPCP default route, that will get a default route from the ISP. Okay. Shivam, this is clear to you? Okay. Now, just say no shutdown because we have done everything. Now we should get a default route. The authentication should be successful and it should get an IP address. Do show IP interface brief. So this is S4 by 0. So look here. First of all, we are getting the IP address. It means that pool is correct and the authentication is successful. Now we have to check the default route. Okay. Do show IP route and look here. We are getting a default route also via this address. And who's this address? .21 is your R12. Okay. So guys, any doubt till this point, just tell me. If you have any doubt, I can start this ticket again. Shivam, Abhilash, any doubt till this point? Shambhu, any doubt till this point? Okay, now the next thing what we have to do here, we have to check the telnet connectivity from R11. Okay, now, so in this diagram, before checking the last connectivity, the telnet connectivity from R11 to R17, what we have to do, we have to check the communication in between R11 and R12. Okay, so right now, as I can see here, this is a EIGRP domain, R11, R12, 13, 14, this is our EIGRP domain. Okay, so now let's back to the next ticket, this EIGRP. So basically what we have to do here, we have to configure this EIGRP ticket, then only we can achieve that task. So right now what I will do, I'll just do a single configuration. I'll just make a reachability in between R11 and R12. Okay, and we'll check the connectivity, everything will check, and then we'll go to one by one to the next tickets. Okay. So this is R11. Do show IP EIGRP neighbor. So right now we do not have any neighbor here. So right now, first of all, I will check the configuration. Maybe we can have here any ACL, any other issues, right? Do show run pipe section R EIGRP. This is router EIGRP. So I want to check a section with router EIGRP. So the network is running 145, cool. So this subnet is having 145 network, perfect. Passive interface 2 by 0, 3 by 0, 0 by 0. Okay, so 2 by 0 is done, no problem. We can passive this interface. 3 by 0, cool. Not E0 by 0, right? So whenever you configure passive interface, it means the device will never send any hello packet on that interface. And if a device is not sending any hello packet in OSPF, in EIGRP, in that case, the device will never form any neighborship with that neighbor on that segment. Okay. So let's remove this command, router EIGRP 145. No passive interface, E0 by 0. That's it. Do show IP EIGRP interface. Okay. Do show IP EIGRP neighbor. Cool. Now this neighbor is up, .2 neighbor is up. So you can see 145.67.89.2. This neighbor is up. So this is your R12. Now I will try to do a communication with R17. Okay. Telnet 145.67 89.22. Okay, destination unreachable gateway or host town. So first of all, I will check my routing table. Do I have any route here or not? Okay, to reach that neighbor. So that is 145.67.89.22. Yes, we have that route here, correct? So right now, first of all, I will try to communicate to this end, 21. It means I'll try to communicate to R12 and then we'll check the issue in between R17 and R11. Okay, just do a ping 67.89.21. Okay, so till this point we can do a communication, but not to 22, right? So that is unreachable. So maybe we can have some issues there. Let me try to do a trace, then we can verify. I think 145.67.89.22. Okay, so in this trace route, I'm getting AAA on which hop dot 22. So in my previous sessions, I have told you about the trace route, about A, about H, and about star issue, right? So as I can see here, we are getting dot 22 and then AAA. It means on this device, we have any ACL, we have some ACL that is denying the traffic, right? So let's go to R17 and we'll check the ACL and we'll modify that ACL according to this telnet. Do show run interface as 4x0. Okay. So look here. We have ACL here with the name Uber 17, R17. Okay. So let's set the ACL, what we have in this ACL, and allow the telnet services. Okay. Okay, so this is the extended ACL. So we are just permitting these things. Just do one thing, run this command and permit TCP, source is any, the destination. So I'll choose my own interface and equal to telnet. So we will never try to do any action. Okay, we'll try to enter some commands in the ACL, in the prefix list, in the route map, a specific command. Okay, so right now, as I can see here, the permit TCP any, source is any, host is this one, if the destination is this one, and if the packet is equal to telnet, then only allow the packet. Okay, enter, do WR. Now let's go to R11. Again, just do the telnet. Perfect, that is working. And look here. Now we can access R17 from R11. So this ticket is done. Okay, so we have done here PPP configuration, right? The troubleshooting of PPP. We have done the PPP IPCP command, the meaning of this command, right? The authentication we have done, and the pool we have used. One more thing here, I told you, like, we can have two type of pool. One is DHCP pool and one is local pool. We can have local pool also. So let me go to R12 and we'll show you the configuration of local pool. If you get any configuration for the local pool, so you can configure in future. Do show run interface as 4x0. Interface as 4x0. Peer default IP address. So now we have options here. One is DHCP and one is pool. If I choose pool, now we have to put up local pool name. So this is your local pool, not your DHCP pool. Okay. And how we configure local pool? IP local pool, the name of the pool, let's say new, and then the range. So now we can use a range. So we have two types of pool. One is what DHCP pool and one is local pool. So in the PPP, what we can do, we can use DHCP pool and we can also use a local pool. Okay. So this ticket is done. The ticket number 2 is done. So guys, if you have any doubt in this ticket, just tell me. You can ask any questions in the PPP, authentication, anything if you have. Abhilash, Tushar, Somesh, Jigar, Shivam, Shambhu, any doubt till this point? Anirudh, any doubt till this point?
No, sir.
Okay, cool. Now I think we can move to next ticket. Okay, so the next ticket related to OSPF. Assume that there is a server located in OSPF area 1 on the link between R21 and 22 in the global service provider network. Okay, so let me show you this design, the OSPF design. Okay, so we have this OSPF design here. Okay, so we have R21, R22, R3, R5, and R1. So these 5 devices are the part of, okay, Abhilash, any doubt till this point about the DSP and local pool? Both are same basically. Okay, we can have a pool there, right? In the local pool, we can just define the IP addresses, the range, but in the DSP pool, we can have multiple options, right? In the DSP, we have options, correct? So DHCP, we can use for multiple parameters, but if I talk about local pool, so that is just a local pool, that's it. That will be having only IP addresses, the range of IP addresses, that's it, nothing else, okay? So if we have triple P, if I don't want to give any special permission, any special default gateway or anything, any parameter, so I can just simply use a local pool. Or if we have a requirement to give default router, domain name, or any other option, so we can use DHCP pool, okay? Abhilash, this is clear to you now? Okay, perfect. Now let's start this ticket. So we can see here R21, 22, R3, R1, and R5. So these 5 devices I'll be using for this ticket. Okay, this is OSPF ticket. So in between R1, R3, R5, and R21, 22. Tushar, any questions? Yeah, sure. I'll check your previous comment. Just wait. Yes, Abhilash, like the DHCP, other options will not be available in the local pool. That is a part of DHCP only. That's why. Tushar, if you have any doubt, you can paste your comment again. I cannot find your comment, the previous comment. Okay, I think we can continue. Okay, so we have to run here OSPF, right? So before checking the other things, let me again go back to this one. So assuming that there is a server located in OSPF area 1 on the link between R21 and 22 in the global, okay, cool. The NOC team has identified that the traffic that originated in OSPF area 0 and destined to the server is not load balanced by R1, fix the problem. Okay. So basically what we have to do here, so we have to do a ping or trace route to a server that is in between 21 and 22. It means we will be having the network ID of 21 and 22. That should be load balanced via R3 and R5. Okay. So on R1, I will do a trace, I will check the connectivity, I will check the routing table, and we should have that route towards R3, towards R5 also. That's it. This we have to achieve here. So before checking these things, right? So we have to check the OSPF connectivity, right? So the OSPF output and those things we'll discuss later. Okay. First, we'll check the neighborship in between 21, R3, R3, R1, R3, like these neighborship we will verify. Okay. So let's start with R1. Show IP OSPF neighbor. So right now, as I can see here, one single neighbor, that is 2R2, right? So right now we don't have any neighborship with R3, with R5. So let's verify what is the issue in between these routers. Show IP OSPF interface brief. So now we will verify, we will check this one. Do we have OSPF on the interface E1 by 0 and 2 by 0? So yes, on E1 by 0, E2 by 0, we have OSPF, right? Now let's check the OSPF configuration. Maybe we can have passive interface or any other feature there to deny the traffic. Do show run pipe section R OSPF, the section of OSPF. Okay, so the router ID is correct, 23111. This is the router ID of R1, and the network we're using is any for area 0. So everything is fine till this point. Just verify the last thing, that is interface. Okay, everything is fine till this point. Everything is fine. It means on R1 we do not have any issue. Let's move to R5. Okay. Show IP OSPF interface brief. Okay, so as I can see, 2 by 0 is in down state. Let's check why. Show IP interface brief. 2 by 0 is in shutdown state. Let's enable interface E 2 by 0. Just say no shutdown. Again, go back to the output. Do show IP OSPF interface brief. Okay, so that is getting up. Okay, so what we have here, 0 by 0 is connected to R1, and I can see that is up, right? Let's back to R1. Do show IP OSPF interface brief. Sorry, show IP OSPF interface brief. So I can see here, 2 by 0, that is also up and running, right? So can you check the output? What is the difference between these outputs and what is the issue here? I will open parallelly, just wait. This is the output of R1. And this is output of R5. Just check the configuration and tell me, what issue we can resolve here to form this neighborship? R5 is having an interface E0 by 0 and R1 is having interface 2 by 0 connected to R5. Any idea, guys? Okay, yes, we have to change P2P. Yes, Deepak, we have to change the P2P here, right? So as I can see here, P2P and the R1 is configured on DR, BDR, right? So what we can do here, we can do a changes here, correct? So let's make it P2P everywhere, okay? No worries. So I can configure here P2P to DR, BDR to multi-segment, or we can configure the R1 as P2P. Okay, so let's configure R1 as P2P. Or change it this one, no problem. Interface is 0 by 0. No IP OSPF network. This will fall back to the default. Okay, that is a wait. Just wait. Okay, Shambhu, you're saying E2 by 0 is in different area. So no worries. I forgot to tell you one thing. R3, R5 and R1. So these three routers in area is in area 0 and R21, R3, R5, R22. So these routers are in area 1. So this is our area 1 OSPF. Okay. So E2 by 0 of R3, E2 by 0 of R5 will be in area 1 and 0 by 0 and 0 by 0 will be in area 0. Okay. It means R3 and R5 will be AVR here. Okay. Do show IP OSPF interface brief. Still, we do not have any neighborship here, right? Let's check. Go to R5 and verify the commands. Do show run. Let's run this command. Okay, both are DR, but we do not have a neighbor count here. Do show run pipe section R OSPF. Okay, so first of all, we can see here the router ID is 134.22.22.22. Okay, so that is a router ID of R22. We have to choose a router ID of R5. Okay, so let's verify what is the loopback address here. This is 123.5.5.5. Okay, so router OSPF 1, router ID 123.5.5.5. That's it. Do show run pipe section R OSPF. Okay, so again, one more thing here, the max metric router LSA. So guys, any idea about this one? What is this max metric router LSA? What is the meaning of this command? Any idea? Shambhu, Shivam, any idea? It sets router LSA as having max metric. Correct. So once we configure this command max metric router LSA, in this case, what will happen here? R5 will start advertising all the LSAs with maximum metric, right? And in what condition we use this feature? Let's say I want to make a router as least preferred, right? So I can configure this command. So what will happen here? This will be the last hope. Let's say we have a network and I want to configure R5 as a backup path, we can say. Okay. So in that condition, if any of path is available, so that routers will go via that router. If all the paths are down, then only in the last, the routers will go via R5. It means last preferred router. Okay. So using this one, the device will increase the metric of all the LSAs. Okay. 265535. Basically what happens here, whatever metric, let's say we have metric 10. Okay. For the LSAs. So what will happen here? Once it will advertise the LSA to next router, it will add 65535 in that 10. Okay. And then it will start advertising the route to the neighbors. Okay. So let me remove this one because right now we don't need this max metric router LSA. We don't need the passive interfaces E0 by 0, 2 by 0. It means using passive interface in EIGRP, I told you, whenever we use passive interface, it means the device will not send any hello packet. And if the device is not sending any hello packet, it means the device will never form any neighborship. Okay. So I'll just remove this passive interface feature. Enter. Do WR. Do show IP OSPF interface brief. Okay, look here. On E0 by 0, we have one single neighbor. So in between R1, R5, the connectivity is fine. Cool. Shivam, what you missed? Okay, the route max metric router LSA. So basically, once we configure max metric router LSA, what happens? The device will start advertising all the route with a higher metric. What it will do, it will add a metric 65535 to all the LSAs. That's it. And if the device will advertise a higher metric route, that will be less preferred. Okay. And in the case of backup or least backup router, we use this feature, max metric router LSA. Okay. Shivam, this is clear? Okay. So now let's check the neighborship in between R1 R3. Okay, so the issue in between R1 R5, that is done, that is clear. Okay, now let's go back to R3 and we'll verify the issue. So the same configuration we can verify, we can have passive interface, the router ID can be different. So these things we can verify. These are the initial steps. Show IP OSPF interface brief. So again, as I can see, this is P2P, just change it to default. Interface E0 by 0, no IP OSPF network. It will fall back to the default. In wait state, just wait. Let's verify the passive interface also. Maybe we can have that command. The router is correct. Okay, yeah. So just remove this command, the passive interface, so it will start sending the packets to the neighbor. Okay, done. Go back to R1. Okay, cool. Now on 2 by 0, we have a neighbor on 1 by 0 on 0 by 0, right? Do show IP OSPF neighbor. Perfect. So we have a full neighborship with R5 with R3 also. Perfect. So it means what we have done till this point, the troubleshooting in between 3, 1 and 5. Now I will verify the neighborship in between 3 and 21 and 5 and 22. Okay, so let's start with 3 and 21. Show IP OSPF interface brief. So this is our E0 by 0. So again, that is P2P. On R3, it was DR BDR, right? Interface E0 by 0, IP OSPF network. Just say it now. Do show IP OSPF interface brief. This is in wait state, but we cannot see any count here, no neighbor count. Just wait. Maybe it will receive the packet. Or we can verify the configuration also. The router is correct. Again, the passive interface. So everywhere we have this passive interface. Perfect. Let's go back to R3. Do show IP OSPF neighbor. And yes, we have a neighborship with R21. Perfect. Okay. Now let's go to R22 and again we'll check the same configuration. Why we don't have a neighborship in between 22 and R5. Okay. Show IP OSPF interface brief. Okay, on 0 by 0 we don't have a neighbor. So but that is DR. It means that is fine, no problem. Let's check the passive interface command. Show run pipe section ROSPF. Okay, so yes, we are using 0 by 0 as passive. So just remove this command. I think the neighborship should be up now. Yes, the neighborship is up. Cool. Okay, so the neighborship is up. Now let's verify the output. Okay, so the address we have in between 21 and 22, that is okay, 134 56 78 dot. This is 49, this is 50, it means that will be 48. So just go to R1 and verify the output. That should be load balanced only. Do show IP route. So that was 134 56 78. So right now we are just getting a summary. So we are getting a summary of 134 on /8, and who's sending me the summary? .18 is sending me the summary. So from R5 we are getting a summary, but we should get a specific route, right? So just go to R5 and check why the router is sending me a summary. Okay. Go to R5. Check the configuration. Okay, so we are using area 1 range this command. So using this one, what happens? Let's say in a different area, if I want to send a summary address, right? On ABR, we can do a summarization, right? So this is the command to do a summarization. So what I'll do here, I'll just remove this command to remove this summarization. Okay. Say no to this command, do WR. Okay. Go back to R1, just verify the same output again. Okay, perfect. Now we're getting all the specific route from those routers, right? So 48, yes, I'm getting 48, but only from 18, not from R3. So this 18 is our R5. Just go to R3 and check that I'm getting the route from R21 or not. Okay. Okay, this is, I'm getting from .38. And who is 38? Yes, perfect. Means I'm getting the route. So R3 is getting all the routes till this point, but R3 is not advertising the routes to R1. So let's check what is the command on R3 that is denying these routes. Do show run pipe section R OSPF. Again, we are using area range command. Just remove this command. No, say no to this command, do WR, just to save the configuration. Okay. And go back to R1, just verify the same output. Okay. 48, I'm getting only from dot 18, not from the router. Just wait, maybe it will take time. It is not advertising the route. Okay. The reason we can verify. Okay. So now let's check the database. So first of all, I will check the database that I'm getting the database or not. Then only in the database, it will try to install the route in the routing table. Correct. So before checking the routing table, now I will verify the database, the OSPF database. If I'm getting the routes in the database, it means we have some issues in the database. That's why the device is not able to install the route in the routing table. Okay. So this is OIA route. It means that is OSPF intra-area route, that is LSA3. OSPF inter-area route. Okay. Show IP OSPF database. So this is summary netlink LSA, and I can see I'm getting this route. You can see one I'm getting from R3, one I'm getting from R5. Okay. So, but the device is not able to install the route in the table. So I will show you the output and you have to figure out what is the issue in this database. Why the device is not able to install the route in the routing table. Okay. Do show IP OSPF database summary 134.56.78.48. So we always choose a link ID to check the view of the database. Okay. So this is the view of database. This route I'm getting from R3, this database I'm getting from R3, and this database I'm getting from R5. Check the output and just give me the solution, what we can modify to fix the issue. Right, Deepak, this is metric mismatch. So from R3 we are getting a higher metric, and from R5 we are getting a lower metric. That's why the device is installing only the lower metric route. Perfect. Okay. So what we can do, just make it 20. Okay. Let's check the interfaces, why, on which interface we have the higher metric, or we can configure this as 31. Okay. Let's check one by one. How we check one by one? We have to verify first of all this interface, this interface, this interface, and this interface, and one by one we have to change it, right? Or we have to match it. So just go to R21 and verify the interface output. Do show IP OSPF interface brief. So from this path via R3 I'm getting higher metric, and from this path I'm getting lower metric, right? So 2 by 0. So that has 1. Okay, and okay, so this is 1, no problem. On 2 by 0 we have 1. Cool. Let's go to R22. Do show IP OSPF interface brief. And here 2 by 0 we have 10. Okay, so let's make it 1, or we can go to R21, we can make it to 10. Let's go there to make it 10. Interface E2 by 0, IP OSPF cost 10. Do show IP OSPF interface brief. Okay, everything is fine till this point. Let's verify the commands also. Everything is fine till this point. Go to R22. Do show IP OSPF interface brief. Do show run pipe section R OSPF. Okay, everything's fine till this point. Now let's move to R3, R5. On 2 by 0, we can see that is 30. So let's make it 10. Or we can go to this router and can check what is the default cost here on this interface. Okay. So on R3, we have 30. Go to R5. Do show IP OSPF interface brief. So this has 10. So just go there on R3 and make it 10. Interface A2 by 0. IP OSPF cost 10. Do show IP OSPF interface brief. Perfect. Then finally we can go to R1 and can check the database. Okay, perfect. In both database, we can see the metric 20 and 20, right? Do show IP route. Okay, so in the database, we are getting metric 20, but we are checking here in the routing table. For this route, we are getting the metric 30. Any specific reason? Why in the database we have 20? Why here in the routing table we have 30 metric? Local interface cost, okay. How we can explain these things? In the database, I can see 20. In the routing table, we can see 30. How we can differentiate or how we can explain this one? Okay, received cost plus local interface cost. Okay, Deepak. Yes, you're correct. So basically what happens here, whenever we check the database, it means in the database, basically always who can create the database here, the LSA3, only ABR. So whenever we check LSA3, it means the cost in the LSA3 is from ABR to destination. Okay. But whenever we check the routing table, so in the routing table, what cost we have? Local to destination. It means from me to destination, that is the routing table. If I check the database cost is from ABR to destination. Okay. That's why the different cost we have in the database and in the routing table. Okay. And yes, I can see both route in the table. If I do a trace, 134.56.78.49, that should be load balance. Yes, that is load balancing here. Yes, Deepak, the router will always insert the receiving interface cost, always correct. Okay, so I hope this is clear to all of you, right? So this task is done. So we had issues here with the point-to-point connection. So if we have on a single segment, if one is having the different network type, one is having a different network type. So at that time, they will not form the neighborship, right? And we have checked the max MAC router LSC. We have checked the passive interface feature, right? We have changed the router ID and the area range command we have removed from here. And yeah, so these things we have done here. So just tell me, any doubt in this OSPF? Because basically we have done this ticket. If you have any doubt, just ask. Deepak, Shivam, any doubt till this point? Assume received cost plus local interface cost. Basically, this is the concept that we use in all the protocols, even in the layer 2. Okay, but in the OSPF, that we create a database, right? So once we talk about the LSA3, what happens here? Whenever the device will install the LSA3 in the routing table, what happens in the background? It will use a combination of LSA3 plus, sorry, the combination of LSA3s and plus your LSA1. So in the LSA3, it will check the cost from ABR to destination. Okay, so let's say R1 is getting LSA3. Okay, so R3 to destination, that is the LS3 cost, and from R1 to R3, that will find in the LSA1, right? So R1 will be using two combination, LSA3 plus LSA1. So using that combination, it will combine the metric and will show in the routing table only for the LSA3. Okay. Any other doubt, guys? Guys, any doubt? You can ask if you have any doubt. Okay, so I hope everything is clear. Anirudh, any doubt to this point?
No, sir.
Okay, cool. Okay, so let's move to the next ticket, that is EIGRP. So the traffic originating from R11 in the local service provider core destined to loopback 0 of R14 must be load balanced by EIGRP as shown in the example. Okay, so what we have to do, we have to again do a load balancing from R11 to R14 loopback address, and we have to match this output. Okay, so this is the diagram. So we have R11, R12, R13, R14, and we have to match that output. Okay, so right now, again, first of all, I will verify the neighborship in between R14, R12, R14, R13. First of all, I will work on the neighborship. Once the neighborship will be up, then I will start checking the cost, interfaces, metric, these things I will start checking. Okay, so let's start with R14. R14 should have a neighborship with R12 and R13. Same, I will go to 12 and 13, we'll check the neighborship with R11. Okay. So I cannot see any neighborship here. Do show run pipe section ROA EIGRP. Okay. The passive interface is 4x0, no problem. That will not cause an issue. Because right now we need to run EIGRP on E0/0 and E1/0, not on 4/0. We do not have any neighbor there. So we can use passive interface for S4/0, no problem. The network we have here 145. Okay, perfect. Everything is fine. Okay, the distribute list I'll verify later. I'll go to R13 and we'll check the issues. Okay. On R14, everything is fine. So I can see here E1/0 and E0/0, both are in passive interface, correct? So let's remove these commands. Okay, now we can verify the neighborship. Okay, the neighborship is up. Let's go to R14. Just cross check the neighborship. Neighborship is up. Let's move to R12. Just check the same configuration. If we find any passive interface, we will remove it. Do show run pipe section or EIGRP. Okay, so for 1/0, we have passive interface. We have to remove this command. No. Passive interface. Do show IP EIGRP neighbor. Okay, everything is fine till this point. But still we have one single that is in queue count. If that is in queue count, it means the neighborship is not up. If you find any neighbor with queue count 1, 2, or 3, it means the device is stuck in any state. But now that is up, no problem. Okay, so the neighborship in between 12, 14, 13, that is up, and even with R11. So let's go to R11. Do show IP EIGRP neighbor. Exit. Do show IP EIGRP neighbor. Yeah, the neighborship is up. Perfect. Okay, so now what I'll do here, we have to check the route. Do show IP route. So we should get the loopback address of R14. So let's verify what is the loopback address of R14. Do show IP interface brief. So, okay, so here we have 145.14.14.14. So let's go to R11 and check the routing table. So look here, we are getting 12, we are getting 13, we are not getting 14, correct? So that is not in the advertisement. So what we will do here, we will go to R14 and we'll check one by one. So in R14, we have one prefix list, I think. Okay, so we'll verify the prefix list and we'll check the issues. Okay. Okay, first of all, let's start with R12, no problem. Do show run pipe section or EIGRP. So we have a prefix list here. Do show run pipe section prefix list. Okay, so in the sequence number 5, we are permitting 000. Okay, perfect. In the sequence number 10, we are permitting 145. In the sequence number 15, we are denying the loopback address. Now just tell me, do we need any modification here in this prefix list, or everything is fine till this point? Any changes we need here? Okay, Deepak, you are saying like remove sequence number 5. Reason? Any specific reason to remove the sequence number 5? We can pass everything beginning. Okay, if I want to pass, so we have to keep that, right? Okay, we can't pass everything in beginning. Okay. Okay, so while troubleshooting, basically what happens, whatever statement we have to work with the statements. Okay, so as I can see, the sequence number 5 is permitting everything, right? So using this prefix list, the device R12 will pass everything. It means if it will receive any traffic from R14, any prefix from R14, it can easily pass to R11. It means this statement is perfect. No need to do any modification in these statements. Okay. Yeah, so you are saying allow sequence number 15, but once on sequence number 5, it will allow everything. It will never go to sequence number 10. It will never go to sequence number 15. Okay. It will just check here everything. Everything is passed. So it will just pass everything, will never come to this sequence, will never come to this sequence. Okay, Deepak? I hope this is clear. Because even in the ACL, in the prefix list, whenever the device find a perfect match in the first sequence number, it will never go to the next sequence number, right? Okay. Now, you're right, but not an ideal condition to do. Yeah, but right now this is a troubleshooting, right? So we have to play with the statements. Okay. So even in the lab exam, whenever you configure the CCIE lab, okay, in the lab exam, you have to play with the same statements. You cannot configure the new statements. You have to play with the configured statements. Okay. And the least modification we have to do in the statements. If everything is fine, if using this statement, using these statements, everything will be fine. So it means no need to do any modification here. Yeah, nothing we need to change here. Correct. So everything is fine here till this point, but now I can see one more thing here. This is offset list. So Deepak, any idea what is the use of this offset list? And what is this one meaning? Add metric to EIGRP routes, correct? So basically we have to check like we are getting some extra metric or not. Okay. So basically we are adding 1000 metric. Let's check what we have in this statement in this ACL. Do show access list. So in this ACL, we are matching permit any. It means for all the routes, it will add 1000. So just do one thing. We will not remove the statement. We will modify the statement. Okay. Let's modify this one. First of all, I will remove this one. And then we'll configure the same with metric 0. It means we have just modified. Okay. Do WR. Yes, Amit. And offset list is a mechanism for increasing incoming and outgoing metric to routes learned by EIGRP or routing information protocol. Yes, correct. Okay, so this is done. Okay, we do not have any other specific configuration. Let's go to R13 and check the configuration. Do show run pipe section or EIGRP. We have offset list here, 1. So let's verify what we have in this offset list. Again, permit any. So again, I'll just remove this statement. I'll just say no to the statement. We'll configure the same statement with 0. It means we are adding, but 0, nothing we are adding. We have to just modify the statement. Okay, cool. Now let's back to R14 finally. Okay, so we have just one single distribute list. Cool. It means using distribute list, what we do, we play with the control plane. Okay. Offset. Okay, Shivam, you have a question. Offset list 1 out 1000 means correct. So basically what happens here, whatever we have matched in ACL 1, it will add 1000 metric into that ACL, okay, to those routes, to those prefixes. 1000, it means 1000 metric, not 1000 routes. Okay, Shivam. In ACL, we have 1, and that is permit any with metric 1000. It means to all the routes, it will add 1000 metric. Whatever metric they have, it will add another 1000 to that one. Okay. So right now, as I can see here, this is distribute list. So using this distribute list, what we do, we basically play with the control plane, right? We deny, we allow the control plane. So check the prefix list. So this is loop 0 prefix list. Okay, cool. Look here. In the sequence number 5, we are denying the prefix. In the sequence number 10, we are allowing the prefix, right? We are trying to allow everything. So what it will do, it will check the first match and it will never check the allow statement, correct? So for the loop back, it will deny the loop back. What I'll do here, I will modify the statement. I will not remove the statement. I will modify the statement and will just say permit. Okay. I'll change the deny to permit. Just say permit. Do WR. And we can go to R11 now. do show IP route. It should get the route now. Just wait. Yep. Now we are getting the route 145.14.14.14, and from both routers, right, we have to match the output. Okay. So do show IP EIGRP topology. What we have to match? Let's check the question. 145.14.14.14/32. This is the output, and this was the question. Okay. So can you see the metric we have? The composite metric is this one. Okay, and here the composite metric is different. Same here, the route is internal. Okay, cool. 1000. The delay is 7000 microsecond, but here I can see that is 1,06,000, right? Okay, so we have to get a lower metric. In this one, I can see the metric 1703, but here we can see the metric 2969600. So right now what we have to do here, we have to use a lower metric, right? So if your K values, you are not using K values, so your metric will be higher. If you are using all the K values, so right, by default, what will happen here, K1 and K3 will be enabled. But right now, to match the same output, we need a lower metric. In the output, as we can see, the metric is very low, right? But here in the CLI, we can see the metric is higher, correct? So we have to use all the K values. So once we will start using all the K values, the metric value will start decreasing, correct? We will change the delay, we will change, no, we will not change the delay, we will change the K values, okay? We will change the metric weight. So we have two things, metric weight, metric component. Metric weight, it means your K values. Metric component, it means your delay, bandwidth, these things. So we will not touch any special configuration here, the interface configuration. We will just modify the K values on all the routers. So if I change on R11, so we have to modify on all the routers. Otherwise, they will break the neighborship. Reason, in OS, in EIGRP, the K value should be same on all the routers. Okay. So router EIGRP 145 metric weight. So first of all, we have toss, just say it's 0, K1, K2, K3, K4, K5. That's it. Do show history. Just copy and paste the same commands to 12, 13, and 14 also. Okay, cool. We have done. Okay, so we have configured all the K values on all the routers. We have enabled all the K values, right? Now let's go here and go to R11 also. Check the output again. FD is still this one. Okay, the delay is higher here, right? So maybe we have some modification in the delay. Okay, let's check one by one the interfaces. Because here in the output, we can see the delay is 7000 microsecond. And on R11, we are getting a higher delay. Okay, so let's verify what is the issue behind this one. So the routers always add the delay and bandwidth on the receiving interface. It means R12 and R13 has to check the delay, okay, on the incoming interface. That is 1 by 0, 1 by 0. So I'll check R12 first of all. Do show interface, do show run interface E1 by 0. Okay, so we have configured here manual delay. So I'll just remove this delay, interface E1 by 0, no delay, it will fall back to the default one. The same configuration I will verify on R13. Do show run interface E1 by 0. Again, here we have delay. No delay, it will fall back to the default one. Okay, let's go to R11 and check the delay again. Do show run interface E1 by 0. Okay, we do not have any delay here. 0 by 0, perfect. Now we can run the output. Okay, cool. Look here. we are getting metric 1703. So exactly same metric we have here, 1703. The bandwidth, the delay, everything is same. So this ticket we have done. Okay. So guys, just tell me, any doubt in this ticket? If you have any doubt, just tell me. Deepak, Shivam, any doubt? Amit, any doubt? Shambhu, any doubt? Okay, so now let's start the next ticket. Okay, so till this point, what we have done the layer 2, right? The spanning tree we checked there, the VLans we checked there, not spanning tree. Okay, and we have done the PPP, the layer 2 functionality we have done there, correct? And EIGRP, OSPF, these things we have done. Now we have BGP. So this will be a big ticket. The network hosted behind internet must be able to be reached from R12. So it means we have to do a trace from R12. R12 should be able to prefer the reachability through R21 and 22, following via R1 and R6, R4 and R6, cool, no problem. Fix the problem so that the following trace route from R12 should produce the same output. Okay, cool. So first of all, I will explain you the design, what design we will be using here. Okay, so this design I'll be using here in this ticket. Okay, so we have R12 here. So using this device, we will do some trace route. Okay, and we have internet here on R32. So the traffic should come here via R21, 22 and via R4, R6. That should be load balanced on R4, R6 and should come to this internet via R21 and R22. Okay, the traffic should be load balanced only to these routers, and then it can go via R21, it can go via R22. Okay, so in between 32 and 21, so right now we are discussing the diagram, what we have in this diagram. Okay, in between 21 and 32, we have BGP neighborship, eBGP neighborship. Between 22 and R32, we have eBGP neighborship again. So via eBGP, R21 and 22 will receive the routes. Okay, 21 is having iBGP neighborship with R3, with R5. Same here, R22 is having iBGP neighborship with R3 and R5. Same here, R3 is having a neighborship, iBGP neighborship with R4 and R6. Same, R5 is having a neighborship with R4 and R6. It means in this condition, R3 and R5 will act as route reflector. Okay. So what will happen here, whenever R32 will send the routes via eBGP to R21, 22, they will just reflect they will send the route to iBGP neighbor, that is R3 and R5. And these both routers will reflect the route to 4 and 6. And finally, 6 and 4 will send the route to R12 via eBGP. So again, in between 4 and 12 and 12 and 6, what we have? eBGP neighborship. So finally, R12 will receive the routes. Okay, so we have to verify this connectivity, what I told you right now. And in the background, the IGP protocol. So as I told you, in between 12.3, 5.22, we are using OSPF area 1, R3, R4, R6, R5, 1 and 2, we are running OSPF area 0. Okay, so the first thing we will check the IGP protocol. So if that is perfect, fine, if that is working, then only we can go to the BGP. Okay. So what I will verify here, I will verify the connectivity. So till R1, everything is fine, right? Because in ticket number 3, we did the task. So now I will verify the configuration. I will verify the OSPF neighborship in between 1 and 2, 2 and 4, and 2 and 6. Okay. So this will be the very first task to troubleshoot this ticket. Okay. Or whenever you get anything like this, if you have BGP and eBGP, route reflector and IGP protocol, the first thing you have to troubleshoot your IGP always. Okay. If your IGP is up, then only you can troubleshoot your BGP. Otherwise, you will not be able to troubleshoot your BGP or overlay protocol. Okay. Now, so I'll start from R2. Let's go to R1 first. Do show IP OSPF interface brief. So I can see here E0 by 0 is connected to R2 with P2P connection, and that is up. Perfect, no problem. Go to R2. Show IP OSPF interface brief. Okay, 0 by 0 is P2P, perfect, no problem. And then we have, okay, it means this IGP protocol is working fine. Okay. Underlay protocol is working fine. So yes, we have connectivity. Now the second thing, before checking the BGP, R1, R2 just have IGP protocol. They do not have any other feature, right? Any BGP session here. So how they will receive the traffic and how they will forward the traffic to other routers. So basically what we are using here, MPLS core. So R1, R2 will route the packet, will forward the information to neighbors using labels, using MPLS labels. Okay. So we have to verify the MPLS also. The first thing, we have to verify the IGP protocol, that is working fine, no problem. Now we have to verify the MPLS label, then we can move to BGP. Okay. So what I'll do, I'll just go to R2 and R1 and we'll verify, do we have MPLS neighborship with these neighbors, LDP neighborship with these neighbors or not? So I'll go to R1. Do show MPLS LDP neighbor. So as I can see here, we have R5, we have R3, we do not have R2, right? So you can see LDP identifier. So if you are aware with MPLS and these things, so this will be very easy to all of you. Okay. And this is R3, cool, no problem. So right now, we do not have any LDP neighborship with R2. So first of all, we'll verify, we'll troubleshoot this one, why R1 do not have any neighborship with R2 in LDP. Okay. How we can verify? Just check the LDP interfaces. Do show MPLS interface. So as I can see, 0 by 0, 1 by 0, 2 by 0. Yes, on all these three interfaces, MPLS is enabled, no problem. Just go back to R2. Run the same command. Do show IP. Show MPLS LDP neighbor. Again, we have a neighborship with R6. We have a neighborship with R4. Perfect, no problem. We do not have a neighborship with R1. Show MPLS interface. Okay. So MPLS is enabled only on 1 by 0, 2 by 0, not on 0 by 0. So just go to interface. Is 0 by 0, just run the command MPLS IP. So using this command, what we do, we enable here MPLS, or we can say the in the background, it will be using LDP protocol, label distribution protocol. Okay. Do show MPLS LDP neighbor. Okay, perfect. Now we have three neighbors. R6 we have, R4 we have, and R1 we have, right? So we can see here, this is the first pair. This one is the second pair. And finally, we have the last pair. Okay, it means everything is fine till this point. Perfect, no problem. Now we can check the BGP. Okay, the IGP is done. No issues in the IGP. MPLS is also fine. Right, now we'll check the BGP. We'll check the only neighborship. So before checking other parameters, we have to verify they should have the neighborship, then only they can exchange the route. So in future, once they will not exchange the route, then we can check other conditions, check other parameters, attributes, we can verify. Before checking other things, we have to verify the neighborship. So the OSPF we have done, the MPLS we have done. Now we'll check the BGP neighborship. It means I will start from again R21, 22. We'll check eBGP with 32 and 32. So I'll start R21 and 22. We'll start checking eBGP. Do show IP BGP summary. So this is .6. Yes, this is my eBGP neighbor. As I can see, the AS number is different. So it means that is eBGP neighbor. All good. .6 is the address configured here. .6. I'll go to R22. Do show IP BGP summary. Perfect. We have another neighbor eBGP neighborship with the router. All good here till this point. Now I will go to R3 and R5. Do show IP BGP summary, and this is your route reflector. We have a neighborship with 21, 22, all good, 4, 5, 6, but those are not active. We'll see the issue why those are not active. Okay. Now we can go to R4 first of all, or what we can do a ping to that loopback address. If that loopback address is available, it means we have some other issue. Otherwise, we have to troubleshoot why that issue is not, why that address is not reachable. Now, just do a ping. Do ping 123.4.4.4. Okay, that is not reachable. Okay, so we have to verify why that is not reachable. So I'll just do a ping one by one, or I can go to R4, can check like we are getting the route or not. So do show IP route 123. Look here, we have the route, but that is not reachable. Maybe we have some issues in the core network. Let's do a trace route. Do trace. So using trace, we can identify the router on which hop we have issue, right? So that address was 123.4.4.4. Okay, we are not sending packet out even here, right? So maybe we can have issue on R1 also. Let's check what is the issue here. R1 is not giving any reply, correct? I will try to do a trace from R4 and we'll see what happens. So from here, from R3, I'm not able to get reply from R1, no problem. I'll just check from R4 also. .123.3.3.3. I'm not getting reply from R2. Okay, no problem. Let's come here. Let's do a ping to R1 first. That is reachable. That is not reachable. It means R1 is giving reply only for those local routes, but not for R2. It means we have some issues on R1. Okay, so let's go to R1. We'll verify the issues, what issues we can have there. Okay, so do show IP route. We have everything here. We have all the routes for the reply routes. Yes, we have all the reply routes, right? Now let's check the ACLs. Maybe we can have ACLs here, right? But we don't have any ACL, because if we have ACL, so we should get AAA in the trace route, right? But still we can verify do show IP access list. Yes, we do not have any ACL. Now let's check that forwarding is enabled or not. Do show the MPLS is working here. Okay, so do show IP sef. Look here, the CEF is not running. Okay, so if the CEF is not running, the device will not be able to send your routes using MPLS. So because we are running MPLS here, right? This will not work. So just enable IP CEF through WR. Perfect. We have all the routes in the table now. Go to R2 and just verify the same thing. Do show IP CEF. Okay, the CEF is enabled here. And now let's check the trace route from R3. Trace 123.444 memory. Okay, cool. Everything is fine. Right, now we can verify the BGP neighborship. Okay, look here. Now the neighborship with R4, R5, R6, that is all good. We have to verify one more thing. R3 should be route reflector. So we have to just verify that command. So yes, the route reflector client is enabled. All good. Go to R5 and check the same configuration. Do show IP BGP summary. Everything is up. This is your route reflector. All good, no problem. Okay, let's go to R12 and we'll check the EVGP neighborship with R4 and R6. Okay, so for .45, .46, the neighborship is up. Guys, just give me a minute. Huh? I'll be back. Just 1 minute. Okay, so everything's fine till this point. Now let's check the routes and we have to match those outputs, right? So we have to do a trace to this route. So let's check, do we have this route or not? So yes, we have that route, but right now I'm just getting this route only from .45, not from .46. So the first thing we have to troubleshoot, we should get this route from both routers, from R4 and from R6 also. Okay. So on R6, I will where .45 is address of R4, .46 is the address of R6. Okay, so we'll verify why R6 is not sending me route or why R6 is not receiving the route. Okay, so let's go to R6 and check the issues. First of all, we will verify like R6 is getting the route or not. So 888, yes, it is getting, but you can see we are getting the route with the next hop of .45. So this is the big issue here. Okay, so let's check the BGP table. So I'm getting 888, the next hop is .45. Okay, this is the issue. Okay, now let's check from where we are getting this route. So BGP 888, if you want to check the detailed view. So look here, R5 is sending me a route with the next hop of .17. That is perfect, no problem. Even that is not correct because the .17 is the address of R1. So we have to go to R5, and if that is using some special configuration, some route map, so we have to remove those things. Okay, and on R3, on this one R3, I'm getting .45. So this is the address of R4. So it means both routers are using some special permission, some special route map to manipulate the next hop. So just go to R3, R5, and whenever on RR basically, whenever we send any route, whenever we configure RR, we never change the next hop, right? Because RR is a part of same domain, and the RR is getting a route from the IBGP neighbor and has to send to another IBGP neighbor. So the good practice is what? Never change the next hop on RR router. Okay. So I'll go to R3, R5, we'll check the route map, and if find any next hop, I'll just remove the next hop. Okay. I'll start with R3. So I can see here a route map CPS out. Let's check the route map. CPS. Okay, so look here, we are setting next hop. So I'll just modify this route map. I will not remove, I'll just modify. Just say no to this command. Okay, just say exit. All good. So whenever we do any change in the policy, we have to clear the process. Do clear IP BGP star soft. So right now I'll do soft. I will not break the neighborship. I will forcefully say please exchange the routes only. Okay. So it will start exchanging the routes. Cool. I'll check the same thing on R5. Okay, we have multiple route maps here. We have two route map, next hop and CPS. We have to check both route map. Okay, one is in indirection, so that doesn't matter. Okay, we can check, no issues. First of all, we'll check. Okay, in CPS we do not have anything, and in next hop, yes, we have. So let's remove these things. So after any changes in the policy, we have to clear the BGP, do WR, right? Now, what we can do, we can go to R6 and can check the behavior, right? Now, we should get the correct next hop. Okay, perfect. So, no, I'm getting here .17, still I'm getting .17. We have to clear the process, no worries. And from R3, I'm getting the address of 21, all good. This we have to clear again, I think. Okay, now it is good. 21, 21, all good, no problem. Okay, now what we have to do here, let's go to R12 because now everything is fine. We'll go to R12, we'll check the routing table again. Still, I'm getting a route only from .46, not from .45. So I'll go to R4 and we'll verify why I'm not getting the route. Or we can check the BGP table also. BGP. So I'm getting that route from R4, from R6 also, but only we have one single route as best route. Okay, so we have to verify why we have this issue. Okay, so what we can check, any idea guys? How we can configure, because look here, if I check the parameters, attributes, everything is fine, everything is same, right? What we can do here to do a load balancing or to make the another route as best route, any specific command, any other information that we can use here? Any idea guys? Guys, any idea? Okay, so attributes we have to use. Okay, no, basically if I check the attributes here, Shivam, so in the attributes, everything is fine, right? The local preference is 100, both are eBGP routes, right? Everything is fine till this point. The question is, one route is best, one is not best. And by default, yes, whenever in BGP, this is the behavior of BGP. Whenever it will receive two best route, it will choose one of them as a best route, right? Both route will not be best route. By default in BGP, one route can be best. The question is how we can make these two routes as best route. We have to do a load balancing here, right? The traffic should be load balanced on R4 and R6. So we have to configure both route as best route. Okay. So just same thing. What we can do here to make the route for this, to make the route via R4 as best. Via R6 that is best, no doubt. We have to make this route as best via R4 also. Maximum path. Perfect. So we can run a command here in BGP. BGP. This is maximum path command. So any idea guys, what is the command? BGP maximum path. So this should be the command, but this is not accepting the command. Maximum. Okay, sorry. Do show run. I think the address assembly is enabled here. Yeah. So if your address assembly is enabled, so you cannot run all the commands in the global mode. Okay. So we have to go into the address assembly IPv4. Run the maximum path. So we need at least two maximum paths. So just run two. So this was the issue. That's why I was not able to run the command in the global mode. So if that address assembly is enabled, so we have to run maximum commands in the address assembly related to the specific neighbor or to control plane. Okay. Do WR. Do show IP BGP. Now you can see, I can see here M. What is this M? The code M, it means multipath. Now both route will act as best path. Do show IP route. So look here, both route are best and they both will be load balanced here. Okay. So let's try to do a trace and we'll match the trace route. Do trace 8.8.8.8 numeric. This output we are getting. So let's match the output. So 45, 46, 45. Okay. We have to use probe 2. So guys, what is a probe 2 meaning? By default, what happens in the trace route, it will send 3 packets to each hop. It means 3 probe to each hop. If I choose probe 2, it means it will send 2 packets at each hop. So now we are sending 2 packets at each hop. 46, 45, cool. 39, 1, 6, 38, 6, and finally 8. Okay. So the first trace route is fine. All good. No problem. We have to check the second trace route 194.111 with probe 2 again. Okay. Trace route 194.1.1.1.1 with probe 2, use numeric for the fast trace route. Okay. So let's match 45, 46, 13, 1. Okay. So now the fourth hop, I'm getting dot 6. We should get dot 18. Now we have to manipulate some parameters. Okay. So in my output, I'm getting dot 6. We should get dot 18. It means what we have to do here, for the specific route 194.111, we have to make this path as the best path. Okay. So by default, what happens here? R3, R5 is getting all the routes from IBGP neighbor and all the parameters are same. So what will happen here? These both routers will choose the best path on the behalf of router ID, the lowest router ID. So R21 is having the lowest router ID, R22 is having higher router ID. That's why R3, R5 by default, they are choosing the best route via R21. Okay. Now, what I'll do here, I'll go to R21 or 22. I will play with some configuration. Okay. I will check, do we have any configuration related to 194 or not, and we'll modify if we have there. Okay. So go to R21. So guys, if you know the attributes, okay, so this will be very easy. Do show run pipe section RBGP. So, okay, so we can see here set local preference. Cool. Let's check this route map, what we have in this route map. So we are sending to my RR. This is my RR route reflector. Okay. So do show run pipe section route map. So this is your set local preference. So this is the route map with set local preference. Okay, so we are matching a prefix with 194. Cool. So the local preference is higher is preferred. So R22 will be sending the LP to these routers as 100, 100. This will be sending 100 by default. So let me just go to R3 and we'll verify the information. The output will be same on R3, R5. So we can check on R5 or either on R3. Do show IP BGP 194.1.1.1.1. So as I can see here, I'm getting the route from 5, my RR client, no issues. We have to verify, we have to focus on R22 and 21. And you can see the LP I'm getting 100. If I will get LP lower from R21, so it will prefer the route via R22, correct? So we have to do some changes here. But one more thing here, as I can see, this next hop is inaccessible. So guys, any idea if I'll prefer the route, if I'll choose this route as a best route, if I'll do a lower AD here, okay, so this will be preferred, right? The device will start using this route, but this next hop is inaccessible. It means the trace route will get stopped there. The trace route will be dropped, the packets will be dropped, right? What we can do here to fix this issue? How we can make this next hop as accessible? Any idea? What we can do here? Deepak, Shivani, Shivam, any idea? What we can do here to fix this issue? The next hop is inaccessible. Okay, let me tell you, no worries. So what happens here? I'm getting a route from my IBGP neighbor, but the next hop is of R2032. That is EBGP neighbor, right? It means basically whenever a router that is getting a route from EBGP neighbor and is sending the route to IBGP neighbor, we have to change the next hop by using the command no IP next hop self. IP next hop self, sorry. Okay, so we have to go to R22 and have to run the command. So just go there, 22, do show run pipe section RBGP. So right now towards IBGP neighbor, I cannot see any update source, anything those things I cannot see. Okay, so address assembly IPv4, neighbor internal, yes, next hop self, and update source should be, okay, that update source, I think that is in global mode. Yeah, update source is there and we have to use next hop self. Just clear the policy, do clear IPBGP star soft. So this is clear. Okay, now we can go to R20, R3. Just check the output again. Yeah, now that next hop is accessible. Perfect, all good. So right now, as I can see, that is best via 21 and I will play with LP. So that is the first criteria that we can play. Okay, so I'll go to R21 that already has a route map with same local preference with, sorry, route map. So this route map is having prefix list 194. So let me check this prefix list. Do we have that route here or not? So in 194, we are permitting this one. So we have to remove this one. We have to modify this one. So I will modify this one and we'll put here 194 subnet. Okay. So we have to verify first of all what subnet we are getting in the BGP table. So like BGP only. So we are getting 194.11. So we have two routes, 194.100, 194.110. So this will be the most preferred. So we have to play with this route, 194.110. R21. So remove this one. Configure this one. 194.1.1.0 on /24. Okay. And we have to set the local preference also. Set local preference 90. Do clear IPBGP star soft. Do WR. We can go to R3 and can see the information now. Okay, look here. Now that is best via this way because now from here I'm getting LP 100. From here I'm getting LP 90. Perfect. Now we can do a trace from R12. And look at now that is going via 18, 42 and 14 that we have to match, right? 18, 42, 14. Perfect. So this is done. Now the next trace route from R12 to R3 in 21. Perfect, no problem. I'll do. Okay, but here we don't need to do a load balance, right? So for this route, the traffic should go to 45. Okay. It means from R12, if I want to reach R3, the traffic should prefer R4 path. No problem. I'll go to R12. We'll check the attributes. Show IP BGP 123. Okay, so I'm getting this route only from R4, not from R6. We should get the route from R6 also. Then we have to manipulate the parameters. Okay, otherwise this will be issue because if this link goes down, I will not be having a backup path. So if we have two connections, so we should have a backup path, right? So we have to verify why R6 is not sending the route to R12, and once it will start sending, and then we will check the attributes again. Okay, so go to R6, show run pipe section. Okay, let's do one thing. Do show IP BGP neighbor 123.45.67.44 advertise routes. So we are not sending the route. Okay, it means we have some policies. Definitely we have some policies. Okay, we have a route map made in our direction. Route map mad. Okay, so this is the route map mad where we are matching 123, match IP address 123. So let's check this ACL, what we have in this ACL. Okay, show run pipe section X. So like this, one by one we have to check everything. So that is permitting 123.0.0.0. Okay, all good. Let's check that, like we have that route or not. Yes, we have that route. So IPVGP 123.3.3.3. So one I'm getting from R3, one I'm getting from R4. Now what is, so via R3 I'm getting metric 31 and this I'm getting 30. Okay. So this is because of metric. So let's check the issue. The next stop here we have 9. Cool. Okay, the best is via R3, no worries. The med here we have 0. But we are not sending the route to R12. Again, let's check the configuration. Show run pipe section RBGP. So password update source configuration aggregate address. Oh, look here, we are sending this one, right? What we can do, we can just remove this summary only keyword. So once I'll remove the summary only keyword, it will start sending the specific prefix also. This was the issue. Router BGP 12345 address assembly IPv4. Just say no to this command. It will automatically remove summary only keyword. We can verify. Yeah. We can add one thing. Just remove this one and just add summary only. Okay. That means we are doing a modification. We are not removing anything. Okay. Do WR. We have to clear the process. Whenever you do any change in the policy, have to clear the process. Go to R12. Okay, now we are getting the route. So right now that is best via this router .46, that is R6, but that should best via R4, right? So look here, I'm getting metric here 100, I'm getting metric here 300. What we can do, we can go to R4, we can lower this metric, or we can go to R6, we can higher this metric. Okay, so let's go to R6, we can hire the metric. Do clear IP BGP star soft to WR. Let's go to R12. Okay, perfect. That is best via R4. Now we can do the trace route. Okay, now that is going via 45, 9, 1, and 6. All good. One more trace out we have in this one. 134, 21, 21, 21, and that should go via R6 now. This should go via R3, they should R4, and they should go via R6. Let's do this trace also. 134, 21, 21, 21. Okay, let's check like here the route or not. Okay, we have from both routers, and that is best via 45. It means that is best via R4. Again, metric here we have lower, here we have higher. We can go to R6 and can lower the metric. So just go to R6, this route map, set the metric to 10. We can use 10, no problem. Clear the process. Okay, go to R12, do your trace route. And look here, now the trace is going via .46. Okay. So in this ticket, what we have done, the basics of OSPF we have done, even the MPLS we have done, the BGP we have done, attributes we have done. Okay. So the next ticket belongs to IPv6, that is IPv6 BGP. After that, we'll discuss the DMVPN VPN with protocol EIGRP. Okay. In this configuration, we'll be using a DMVPN VPN phase 3 with EIGRP. Then we will discuss MPLS L3 VPN. So that will be having everything like VRF configuration will be having the VRF troubleshooting, BGP, MPLS, and these things it will be having. It will include the DHCP also. Okay. Then we'll move back to IPsec tunnel. Okay. DMVPN with IPsec with the crypto configuration. Okay. And then we'll move to DNS ticket and one NAT statement also, the NAT ticket also. So today we'll finish here. Okay, if you have any doubt till this point, so today we have done 5 tickets. Okay, the next time we'll discuss the next remaining 5 tickets. Okay, so guys, if you have any doubt in these 5 tickets, you can ask. Any doubt if you have, you can ask. Shivam, Deepak, Shivani, any doubt till this point? Shambhu, any doubt? Abhilash, any doubt? So guys, if you don't have any doubt, so we can wind up the session. Shivam, Deepak, any doubt till this point? Okay, so let's wind up the session. Okay, in the next session, we will discuss the remaining 5 tickets. Today, we have done the first 5 tickets. Okay, and before next session, just go through with the BGP IPv6, DM VPN. Okay. Yes, Shivam. Yes, we can. You can get the video, no problem. I'll share. You can join the group. Okay. Shivam, instead of using max path to change the best route, okay, we can also use attribute. Look, Shivam, using attributes, we can manipulate the path, right? So at that time, that was the last attribute where they were doing a negotiation, right? So at that time, we have to use maximum path. That is the last command that we can use to do a load balance, right? Using attributes, we can manipulate the path. We can choose best, not best path. But right now, in the task, we need to achieve load balancing. So if you want to achieve load balancing in IBGP, ABGP, we have to use maximum path command. Okay. So that command is there to do a load balancing. Okay, Shivam. So guys, any other doubt till this point? By default, BGP does not load balance to enable that. We need to mention that command. Yes, correct, Deepak. So guys, any other doubt? Shivam, Deepak, any doubt? Okay, so guys, can we wind up the session now? If you don't have any doubts. Shivam, Deepak, any doubt? Okay. Okay, guys, thank you. Thank you for the session. Thank you for joining the session. Okay. Okay, bye guys. Take care.